And we have the cube root of x squared plus 3 times -1 times x to -2 plus 1/3 times x squared plus 3, everything to -2/3 times 2x and times x to -1. Good problem. Can anyone tell us what to do first? Now you can teach this class. Now we can sit down and
Well, the first thing I did was I was gonna find the thing that I could like take out. So I took out x squared plus 3.
okay, we need one more step before that. Can anyone give us an idea?
Oh, don't you fix it?
Yes. Clean it up.
Yeah.
Yes. Same thing. Whatever works for you, whatever a terminology rings a bell to you, write it down. I need to fix it, or I need to clean it up. Okay. So can anyone dictate the first term? Negative x to -2 and x squared plus 3 raised to which power?
1/3.
Thank you. A radical has to be something to an exponent that is a fraction.
Can you move a little bit to the left? Was that all the way to the right?
X to -1.
Okay.
No, it's already in there. I just ran out of room myself.
Oh, okay.
Yeah, you can see it, but it's missing on my paper actually. No matter what I do, it's still missing.
Where did you get 1/3 from? How is that?
Can anyone explain again?
Oh, where? It's on the.
How do we get the power 1/3? Anyone?
It's on the cube root.
Exactly.
Whatever's
The
in
cube
front
root is
gonna
power
be
1/3.
Oh, okay.
And then, yeah.
Good. So then I am done with this part. Now I have to write plus. I have to multiply 2x by x to -1 and by 1/3. When I multiply x by x to -1, what do I get? X, please write it down. Please write it down. X times x to -1. And tell me what you get.
X over.
-x.
We copy the base. What happens with the exponents? I'm taking the 10 points back.
1 minus -1.
X times x to -1, I copy the base. 1 minus 1 is x to 0, and x to 0 is? But if x to 0 is x, how much is x to 1? Okay, so can both be the same?
X to 0 is 1.
Perfect.
Anything together.
So unless x is 0. So we have to write that down. So please remember. So, I'm only taking 2 points back. Just kidding. Okay, so this is 1. So x to 0 is 1 only if x does not equal
0.
Yes. Please remember this is Calc 2 already. Oh, actually Calc 1. And 2. So 0 raised to 0 is not 1. Okay, so we are coming back. How much is x times x to -1?
1.
1 times 2. Awesome.
2.
Times 1/3. So 2 over 1 times 1 over 3 is 2 over 3. Okay.
That's what I was saying, was 2x times x to -1 is 2.
Okay. Sorry about that.
I did it like if you take.
I was fixated on something
negative
else.
1,
And
you turn it into a fraction, and it's
Correct.
2x over x. And it's back to
Correct.
x. X still can't be 0.
so now we have, that's true. So now we have 2 terms.
Sorry,
Yes.
Can you backtrack? Okay,
Yes.
So after 2x and x to -1, you added 1 over 3, which is why.
I'm not adding, it's all
So you
multiplication.
multiplied
Adding will be a totally different
Right,
thing.
right. So
It will
that's
be
why-
7/3.
That's why we got 2 over 3 because
Yes, yes. I multiplied 1/3 by 2x and by x and -1, and I got 2/3. Is this okay? Okay, now I see two terms and they have a common factor. What is the common factor that I will pull out?
X squared plus 3.
And now let's decide upon its power. What will be the power of x squared plus 3?
The smallest one. So
Negative 2 over 3.
Correct. See how it clicks after you spend some time on it? Yes. Okay, perfect. That's all I was trying to say. Okay, so what is left in parentheses?
There's X negative.
Yes, of course.
X negative 2.
Correct. What else?
X squared plus 3 minus 2 and
Yeah, minus-
2/3, so we have 1. So it'd be,
Yes. Okay, you're there. Okay. I, for some reason, I thought you were already there. Okay.
yeah,
So it's 1,
so
yeah.
1, so it'd be in parentheses x squared plus 3.
Very good. Very good. Awesome. Now I reach the plus. What is left?
2/3.
Very good. So this goes to the denominator as x squared plus 3 to 2/3. Now I distribute negative x squared to x squared. I'm sorry, negative x to negative 2 to x squared. What do I get? Correct, and what do I get? Careful, look at the sign. Exactly. Very good. Very good. And now,
Plus
careful, I distribute negative x squared to 3
minus 3 plus 2
over
1,
over.
2, X.
Very good.
Can you tell me how you get that again? 3 over x
I have to multiply these two, and x to negative 2 means 1 over x squared.
Yeah.
So negative 1 times 3 is negative 3, and x to negative 2 is 1 over x squared.
Plus 2 over 3.
Very good. So next step. Next step.
Would it be
Negative 1.
I have to find the least common denominator, but you're right, negative 1 plus 2/3 would be negative 1/3. I agree with that. So negative 1/3 minus 3 over x squared. Honestly, I would like to take the negative in front and make those two positive, so I don't have to worry about negative and negative. Who knows? I may forget about it. What is the least common denominator at the top? Very good. We only started, what, 3 weeks ago? Right?
Yeah.
You learned O12 with me in class in 3 weeks. This is O12, really. So, the top,
X squared.
awesome. The top,
3.
awesome. What do we have here? Remember, I took the negative in front. They're both positive now.
X squared plus
Very good. So remember, this is over 1. I copy the top, and I flip the denominator. Exactly. And this is it. And no one can further simplify it. Any questions? Good question. It was a good example. Anything else?
I have a question.
Yes.
It's from the study guide you gave us, number 12. It talks about translation and
Yes. Graph functions and transformations and determine the X and Y-intercepts algebra. Go ahead. Okay. So what was the problem with this? What is not clear?
I remember you saying that I can't touch the absolute value.
That's for equations and absolute value inequalities.
So I still know where to start.
So in order for us to graph a function using transformations, Where is the starting point? Anybody?
This number solved?
Say it again?
Is this number solved?
Yes, I think so.
Transformation on X.
On, careful, on,
Absolute value X.
clear?
Yes.
Okay, good. So I start with the base function. What is the next transformation in order of operations?
X minus 5.
Perfect. Which does what?
Move it to the right one.
Exactly. Right shift of 5. Awesome. Next step.
The stretch.
Yes. 2 times the absolute value of x minus 5. What does it? What is this transformation doing to number 2? Yes, vertical stretching by a factor of 2. Very good. Number 4. What does 4 do to number 3? Very good. Reflect with respect to what? Yes. I have a minor piece of bad news. I can't find the lecture notes from last time. You have the videos, but I just can't find the lecture notes. But normally I misplace things. I don't lose them, but I'll try to find it. Okay, final step. Number 5 is on number 4.
Plus 4.
Yes, plus 4. So which means up 4. Okay. Now, can you graph these transformations without me having to do it and just determine algebraically now the x and y intercepts? Yes? Is that a yes? Is that a no? Yes? Okay. So how do I find the x-intercept for any function? Awesome. So this is my -2 x minus 5 in absolute value plus 4 equals 0. This is a perfect example of an absolute value equation. What would be my first step?
Minus 4.
I forgot to ask. What type of equation is this?
Absolute value X.
I just said it. I'm checking to see whether you are paying attention here. Okay.
I hope that's not one.
Okay, so next step.
Divide by
No.
Minus
the
4.
absolute value X. You said
Yes.
we already said, but we said that. We already said minus 4.
Oh, I'm sorry. I know I talk too much.
Okay.
Okay. So the idea is to completely simplify it, clean it up, fix it, or whatever you want to say. Good. Now what? Remember, you can touch this.
X minus 5 is equal to or negative 2.
Very good. Because this quantity can be 2 or negative 2. Awesome. So then one solution will be x equals. Awesome. So what is the ordered pair? Because remember the. Yes, thank you. As I said, now you can teach. Can I sit down? I mean, you can. So, and x, just a little bit of effort. If you bear with me and move forward with me, you'll be happy. Very happy.
Plus 5.
So it's 3, 0. Very good. And by the way, there is a chance, if you're interested, you can tutor math in the math.
Right.
Baby steps here, one step at a time.
Never mind. Okay, how do I find the y-intercept? I can't find 7 people. Okay, y-intercept, what do I do? Very good. So I have to find f of 0. So let's find it together. 0 minus 5. Absolute value of -5. 5 times -2. -10 plus 4. The ordered pair. Okay. So that's your checkpoint. After you present the transformations, you know the correct x and y intercepts. Very good. Anything else? I'm sorry? Yes. Anything else?
Can we just do the exact question?
Oh, yeah. This is short. Yes. Because you show that f of negative x equals f of x, and that's characteristic for an even function, which means symmetric with respect to the y-axis. Yes.
Just do this exact question.
Can we just confirm again? Just
Yes.
just
Yes.
going through the chart.
Okay, is this the last one, or we can continue with something else after this? Yes? This one?
Yeah.
Yes.
Well, this is the double workup today.
Which is good, I need it. Okay,
Alright, so f of x equals this.
what, that was two.
This
So,
is number 8.
okay, so f of x equals,
Square root of x squared minus 9 minus square root of x plus 7.
Good.
So it's find the domain of the function.
right, so,
We just used
Yeah.
it was a different one, we made one up. We
Yeah.
made one up, yes, but you're right.
So yeah, you set them under the square root, you set them greater than or equal to 0.
So, see how the atmosphere has completely changed once my students found the time?
So it's called.
I can win. Okay, just kidding. Okay, so we have the square root. The point I was making is that everyone is answering, everyone is participating, and my heart is in the 12th sky. I don't know if it exists, but you know what I mean. I'm very happy. I'm grateful to you. So what do I write? I have to write a condition for this and a condition for this.
X squared minus 9 is greater than or equal to 0,
Yes,
and then x plus 7 something to 0.
Greater
Greater than or equal to 0.
yes, because it's, yes. But what if this would have been 1 over? What would you have written here?
X is not equal to 7. Negative 7?
No, what if I had, instead of this, 1 over the square root of x plus 7? How would have this changed?
It's not equal to 0.
Right, so how will I have changed this?
Would be x plus 7.
Greater than 0.
Just strictly greater than 0, correct. Because once an expression is in the denominator, it still cannot be 0, no matter what it is. Okay,
So it can't be equal, it has to be greater.
it cannot,
Yeah.
the denominator cannot be 0. Yes, okay, perfect. So now, x squared minus 9,
So x plus 2, x minus 2 is
yes. So for this, I have to use the chart. Unless we can look at another method with graphing and so on and so forth, whatever works for you.
But not for
But-
the other one, not for x
Not
plus
for
7.
this one, because this is linear.
Okay.
So this is linear. I know how to solve linear. That's so if you remember in section 1.7, we had a long list of different types of inequalities. If it's linear, I don't need anything.
Okay.
If it's quadratic or polynomial, then I do need a chart or some other method. This method will not work for this. If it's polynomial, if it's rational, if it's who knows. But if it's linear, I don't need anything. Okay, but this is not linear. And you cannot write this. This will be a terrible mistake. Don't even write it. Maybe you shouldn't even look at what I'm writing now. You cannot write x minus 3 greater than 0 and x plus 3 greater than 0. No, because there are 3 different situations. So you can't do this. You cannot analyze the product by simply, oh, I'm just simply gonna say x minus 3 has to be positive and x plus 3 has to be positive. No, it doesn't work like that.
You could only do that if it was in equal to, right? Because
No.
No?
Yes,
If it was equal to
yes,
0, you could do
yes,
that because
but it would have been an equation. We don't use charts for equations.
Right.
I use charts for studying the sign, whether the result is positive or negative. But when I solve an equation, I just write x equals 3 and x equals negative 3 and I'm done. Right. So then just for this, one way will be to study the sign quickly. Once you understand this, it will literally take you 30 seconds. I am not kidding. Once you understand this chart, it should not take you more than 30 seconds. Just writing it takes longer than thinking about it. So it's negative infinity to infinity. It's a negative 3 for this, and it's positive 3 for this. So 0 and 0, 0 and 0 both have the same positive slope. So I have negative and positive. I'll erase that. I'm sorry. So 2 negatives, positive, 1 negative, negative, and positive. Done. So this should take 30 seconds now. So greater than or equal to 0 will be here and here, which means here and here. So now coming back and writing the first solution, I will have to write negative infinity, negative 3, union 3 infinity. That's my first condition. The second condition is negative 7 to infinity. Now I must intersect these solutions. Why do I have to intersect these two solutions? Because I want both functions to be at the same time. Joey?
Can we just do all three factors in the graph at the same time?
No,
Will we have situations where
because you will multiply 3 negatives instead of multiplying 2 negatives.
So I still got the right domain, even doing all three of them on the chart.
But you may have, by mistake, you have to multiply 3 negatives.
Right.
And then you'll get negative, not positive.
Okay.
So it depends.
Yeah,
It depends on the
how it works out.
situation,
Yeah.
yes.
In this
So you-
situation, it works, but in some
Right.
situations, it may not. Okay.
Right.
Yeah, so be careful on that.
Alright.
Okay, so one more time. Why do I have to intersect the solutions? This and this, because I want both functions to be at the same time.
Right. That's what I was asking for. I
Right.
was asking for both of them.
So my question is, yes, both of them what? I'm missing a word. I want that word. I want to hear it. One more time. I have to intersect these two conditions because both, thank you, say it again. They must be defined. Both functions must be defined at the same time for the same x values. That's why I have to intersect these two. Because the first one may be defined here, and the second one may be defined here, and the function has no domain. If those two don't intersect, the function doesn't exist. Is that clear? So when I intersect so here's what I intersect. I'll have this in green. This is the green territory. And this is the orange territory. So what is the domain of the function f? Not the first part of the function, not the second part of the function, but the entire function f.
Isn't it bracket negative 7,
Negative
comma
seven.
negative 3?
Right, where both colors exist, which means both functions are defined at the same time. So negative 7, negative 3, union 3 to infinity. Does it make sense?
Yes.
Okay.
Did you get the same thing, Joey?
I did, but I can see where it might not.
Exactly.
Might
Be
not work out.
very careful. So you cannot put something. So when you study the sign of an expression, you cannot say, "Oh, let me add this one in here too." It doesn't belong there.
Well, I mean,
Paul?
well, I guess the question, because we work on this one together, so I thought we were using a chart to study how the function behaves over the values, right? So,
I'm using the chart to solve a condition.
right,
I'm not using the chart to
but it's
look
the
at the
same
function.
condition in this case, greater than or equal to 0.
It's not. It's not. What do you mean by greater than or equal to 0? You have to give me the whole thing.
When we were looking for the values, x squared minus 9 before we broke it out, and x plus 7, both were set greater than or equal to 0. That's what I'm saying.
But they're not combined. You cannot combine them.
Yeah, but that's not what I'm saying. Okay, well, I'm not saying we were combining them. I'm saying it's just like how you had to do the.
Okay. So let me write the solution, and I'm going to ask you a question, and maybe that will clear it up. So finally, the domain of function f is negative 7 comma negative 3 union 3 to infinity. Okay. So here's a question for you. So you wanted to add here the x plus 7 in the chart?
That's what we did, and it works out.
You can do that because you cannot combine them. This is one function, function f1. This is a different function, which is function f2. You need to find the domain of the common domain for these two. So for example, if you add this in as x plus 7, you will have -7 here. You will have negative to the left. It will happen that this is positive. But what if you have, instead of x plus 7, what if you have x minus 7? And you have 7 here. Okay, so let me change this into this. So you will have 7 here. And then this part will be all negative, 0 here, and positive. And look, you have 3 negatives, and you will get a negative. So you can combine the functions in a chart.
So it's not gonna work the same.
Yes.
Because I was looking
Yes, you cannot combine the functions. This chart is for this only. You do not need the chart for this. It's a linear inequality.
And so if we have two radicals where they both have two factors under them, we'll do two separate charts and then do the intersection.
Exactly. If the quantities are quadratic or more.
Okay.
Okay. So that was like square root of x squared plus 7.
Yes.
We would do a separate chart
Yes.
for that
So you
one.
have to
Yes,
work
but I
on-
would do it could do them completely separate and then intersect, because you have to intersect.
Okay.
You understand the concept of the common domain?
Yep.
If a function is defined here and one here, you cannot add them because they don't exist for the same x value at the same time. You're not going to be able to plug in anything. So here's an example. So f of x is the square root of x plus 7, and then plus, so this has greater than or equal to -7. So I'm going to put something here that has x less than or equal to -9. Negative here. And negative here. So see, this is negative x minus 9, greater or equal to 0, will be x less than or equal to -9. This is a useless function. You cannot plug in anything.
So if you want to evaluate this function for 0, you can't. This is the square root of 7, and this is the square root of -9, which is not a real number. If you want to evaluate this function for -10, you cannot evaluate this one, but you can evaluate this one. Useless. That was a positive 10, right? For -100, you cannot evaluate this, but you can evaluate this. Useless function. You cannot plug one single x value that makes any sense, because you're not going to be able to evaluate it for anything. So the function doesn't exist, because these two do not have a common domain. You can't pick anything for which both exist, so you can add them. And you cannot pick an x from here for this one and a different x for this one. You can't do that.
Right.
Because the function allows you to plug in one value for x at a time. So this is a useless function. It doesn't have, the two pieces do not have a common domain. No one cares about it. It means nothing. Is that better? Yes? But is it clear what I'm saying?
No, it's not what you're saying.
Yes.
It's just weird that it worked out that time. So it's fine.
Yes. So, as I said, try not to invent things in this class, because they may or may not work. Okay. Is there anything else, or can I move on now? Okay, so let's look at chapter 3. This is not part of this test, obviously. So let me go back to, we have 4 sections in chapter 3. Here they are. I need them before I do the rest of chapter 5 and 6. So we'll continue with this. This will be our third step if you want. And then we'll continue with this as the fourth step. By the first step, I mean chapter 1. By the second step, I mean chapter 2, chapter 3, and then these. Why? Because I need something from 3.7 in these sections.
Okay.
So I can't wait and show you after I need them, right? So that would be test 2. Okay, so we will cover the 4 sections of chapter 3, and then we'll continue.
Test 2 is going to be those 3 chapters, or
It's going to be, yes, so test 2 will be chapter 3. And here, I know it looks scary, but I have to tell you that these 2 are the same with these 2. So it's basically 6-1, 6-2, 6-3, 4, 5, 6, 5-3, and 5-4. These 6-1, 6-2, and 5-1, 5-2 are identical. We will work on more problems, but they are identical. We don't have to do both. Okay? So let's start with chapter 3. The title of chapter 3 is, and you also have, I really like this handout. So, chapter 3 is right here. Quadratic functions and models. Oh, it's all about polynomial and rational functions. So, quadratic functions, this should be very clear. We've seen this before in a different course. Polynomial functions, they're not clear. We will talk about them in detail, and they will be very clear. Dividing polynomials, we'll review that. Real zeros of polynomials, this is optional. I'm just going to mention it. I'm not going to test you on it, but I'm going to mention it. And then rational functions. Okay, so 4 sections. So the title of chapter 3, one more time, is Polynomial and Rational Functions. And there is, as I mentioned today, there is no class work. You automatically have 10 points for today, okay? Happy? Good, me too. I don't have to grade. Just kidding. Just kidding.
Sorry, I'll get 10 anyway.
I got my first 10.
Awesome. Okay, quadratic functions. As we know, we have quadratic functions that look in 2 different ways. Although they mean the same thing, the outlook is different. Ax squared plus bx plus c. And then a x minus b squared, not b, it's h. Plus k, outside. K is outside. Sorry about that. So this is h, but I have to let it dry. So a quadratic function can be given to us like this, in which a, b, and c are real numbers. However, a cannot be y. Awesome. Why a cannot be 0? This is what happens when a is 0. What type of function is this? Linear. So the leading coefficient cannot be 0. It can be positive or negative, but not 0. Because if it's 0, the quadratic function is not quadratic anymore. Okay, very good. So this is lowercase h. Now the second one, we haven't talked about the first one, but we talked about the second one. Can anyone explain what the second one really means?
Transformations.
Right, exactly. So I have x squared, x minus h, depending on h, I don't know. It could be this way, or it could be this way. If a is positive, then this will be this. If a is negative, then it will be this, and then up or down. So this is very clear to us from transformations from chapter 2. We're going to get to it with examples in a minute. Okay, so let's graph your functions and look at models so we can move on. So if you have your book, I'm looking at section 3.1 on page 230.
and page 231. So let's start with, please pick. I'd like to graph a function from 9 through 32. 9 through 32 on page 230. Any function that you would like, because I would like to show you a procedure that is mandatory, please.
About 13.
13. In 13 we have x squared plus 4x plus 3. Perfect pick. X squared plus 4x plus 3. And this is problem 13. The question is asking us to graph. It will ask us to graph, but I'm gonna beef it up a little bit.
These are all the book examples, like easy mode.
True. But wait till you get to calculus, you'll see there's not one easy problem in that book, in my opinion. They all require effort. Okay, first step. Can anyone tell us what type of function this is?
Quadratic.
Thank you very much. What is the shape? There are two possibilities for the quadratic function. As we know, we graphed x squared. How do I graph negative x squared?
Facing the
Right, so x squared has a positive leading coefficient, so then it has a minimum. Very good. So x squared having a negative leading coefficient, you will have a maximum. Perfect. So in this case, how much is the leading coefficient? And remember, this has to be in descending order. No matter what order is it given to you, you have to rearrange it. So it has a minimum or a maximum? Yes, because A is 1, which means positive. It has a minimum. Perfect. Number 2. I want to find the vertex. So this is called minimum, but for any quadratic function, and only for quadratic functions, it's called vertex. So how do I find the coordinates of the vertex? Let me refresh your memory. Yes, what is the formula? The x-coordinate of the vertex is
B over 2A.
negative b over 2a. How do I know this? It's from the quadratic formula. It's everything except the square root. Okay, very good. So let's find it. Negative stays outside. What is b?
4.
Over 2 times a. And the answer is?
-2.
Very good. So I have the x-coordinate of the vertex. Now I know everyone is with me. Good. How do I find the y-coordinate of the vertex? Thank you. So this number must be f of negative 2. Perfect. So f of negative 2 is negative 2 squared plus 4 times negative 2 plus 3. Careful how you replace it. Careful how you apply. Don't do what it's tempting. If it's tempting, it's wrong. So negative 2 squared, 4. 4 times negative 2. So 7 minus 8. Very good. So the y-coordinate of the vertex is negative 2 comma negative 1. Do we all agree? Okay, number 3. X-intercepts, comma, if they exist. Let's talk about this, because I don't want to waste my time, especially in the test situation. I don't want to waste my time if they don't exist. So we agree that this is a minimum.
Yes.
So
The x-axis, so
we can already picture the graph,
Yes.
right? Because the vertex is at negative 2 comma negative 1. Does this graph cross the x-axis or not?
yes.
Yes.
It's clear, because the minimum is?
Below the x-axis.
Exactly. So let me show, I'm going to make a parenthesis here for you to see all 3 possibilities. So for a minimum, this is one case.
The second possibility for a minimum is this. And here is the third possibility for a minimum. On the side, I will write the quadratic formula. So if I have ax squared plus bx plus c equals 0, only if I have this written out, then I can write negative b plus or minus the square root of b squared minus 4ac over 2a. So now we are going to make connections here. So here's my first question. How many solutions, x-intercepts or zeros, does this equation have or function for the first case? How many solutions? How many x-intercepts? None. Okay. No x-intercepts. What does that mean? Awesome. What does that mean? What will that mean when you look at the quadratic formula?
No solution.
Why? What would be the connection between that and this?
So you have a negative under the radicals.
Exactly. This quantity must be what kind of quantity so that the x-intercepts don't exist?
Or they must be negative so they don't.
Exactly. So that is called a discriminant. B squared minus 4ac must be less than 0. And this is the discriminant. It's such an important quantity that it has its own name. Okay, second situation. How many x-intercepts are there? 2. 2, but both the same. She's right. You can say both. I accept if you say one solution, but it's the best is to say double solution. At this point, why double solution? You'll see what happens in the next section. That's why I want you to understand it as a double solution. Same number, not 2 intersect, just 1, but a double solution because it's quadratic. The quadratic equation has to have 2 solutions. So I'm going to say double solution. Can anyone tell us anything about the discriminant?
It's
Equal to 0.
yes.
Awesome. Exactly. This disappears. There is only one solution. Otherwise, I would have had 2 distinct solutions. Okay, last case. Of course, 2 distinct solutions. 2 distinct solutions. One here and one here. Good. And can anyone say anything about the discriminant? Absolutely. Not greater than or, but just greater than. 2 distinct solutions, this must be a positive number. Let's say it's the square root of 4, so I get 2. So I get negative b plus 2 over blah blah, and negative b minus 2 over 2a. Very good. So now we already identified in our case, is it situation 1, 2, or 3? 3. So they exist. It's situation 3, which means the discriminant must be positive. And I'm going to try to solve the equation. Which equation? When I try to find the x-intercepts, which equation do I solve?
Y equals mx plus b. B squared.
It's not linear.
Oh, I'm sorry.
So what do I have to write? For the x-intercept, I have to write something. I have to see it. Nico just told me. You just told us a second ago. With something about something else. How do I find the x-intercepts?
So y is 0.
Yes, that's all I want you to say, so I can write it. So this is x squared plus 4x plus 3 equals, I have to show what I'm doing. So I'm trying to find the x-intercepts. Therefore, I have to set y equal to 0. And now, what do I do?
X
plus 3.
Perfect, thank you, Arvi. If I don't write the equal symbol and 0, then I'll stop and I'll not solve, right? So what are the options then? Perfect, so please give me the two solutions that you just determined as being x-intercepts. That's it. Very good. Number 4. Number 4 is always there, always. What is it? Well, the y-intercept. How do I determine the y-intercept? Indeed, so please make x equal 0 and give me the order pair for f of 0. Very good, so it's 0, 3. Number 5 and number 6 are very important for word problems. And one of them for word problems and the other one for graph. As we know, the quadratic function has a graph that is symmetric. I'm not talking about odd or even, because it can be over 5 or over -5. But it's symmetric with respect to its own axis of symmetry. The axis of symmetry is the vertical line that passes through the vertex. Can anyone give us a vertical line that passes through the vertex? I refresh your memory, is -2, -1. What is the vertical line passing through this point? Thank you very much. Axis of symmetry. Finally, what did we decide that this function had? A min or a max? One more time. Very good. The minimum value of f of x, I need someone to say is? That's where it happens. The y value? -1. And I'm adding number 7 for you. Give me the range, although you can say, wait a minute, we haven't graphed it. We know the graph already. What is the range? That's it. Why this happens? Simply because we know the graph, we graphed it in transformations, and now things become easier for us. Okay, so let's graph this. When I graph a quadratic function, I start with the vertex. One more time, the vertex is? The next step is I have to graph the axis of symmetry. The axis of symmetry is not part of the graph. It will not be a solid line. It will be a dotted line, and it's only supposed to help me keep the graph in shape. My graph will not be perfect anyway, but I have to graph x equals -2. Then I will have to plot the x-intercepts, and you gave me -1, 0, and -3, 0. And then you said 0, 3 is the y-intercept. I know what to expect. I will graph this function as symmetric as possible, not too sharp at the vertex, and I will always write its name next to it somewhere. X squared plus 4x plus 3. I was thinking already at plus 3, and yeah.